Hey everyone, here's another example of a net area problem very similar to the one that we did in class. Right? Again, we have a line, again we have an interval. This time the interval is -3 to 5, so we just have a negative number. So remember that to solve this, we use infinite sums, right? We take an infinite limit. Okay, and that's going to be, the limit as n approaches infinity of f of a plus 1 delta x plus f of a plus 2 delta x plus blah 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 plus f of a plus n delta x. And that's all times delta x. Now remember, delta x is b minus a over n, which in our case is 8 over n. So we're going to replace a with -3 and delta x with 8 over n. Right? So we're just going to get f of -3 plus 1 delta x plus f of -3 plus 2. And actually, sorry, instead of delta x, right, we're just going to replace this with 8 over n. 2 times 8 over n plus blah, blah, blah plus f of -3 plus n times 8 over n, all times 8 over n. Okay, so again, all we did, replace delta x with 8 over n, a with -3. Keeping this going, we're actually going to plug this into f, right? We still keep our limit because we haven't taken our limit yet, but we're going to see what we get. So we're going to get 2 times -3 plus 1 times 8 over n plus, or I should say, -4 plus 2 times -3 plus 2 times 8 over n -4 plus blah, blah, blah plus 2 times -3 plus n times 8 over n -3. Whoops. Ran out of room here. Times 8. Whoop. Times 8 over n. Right? So again, all we did was we plugged this in for x. This in for x. Etc. That looks a little bit tough to see, right? So that's the basic idea. Okay, now it's just a bunch of simplification. So we're going to get, now if you notice, we have 2 times -3, 2 times -3, blah, 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 2 times -3 in every single term. We also have -4, -4, minus, whoop, I wrote -3 there. That should have been a -4. I apologize for that. Don't know why I wrote -3 there. That should be -4. All right, so we have a -4 in every term. So what that means is that we're going to have -6n, -4n. And again, -6n comes from the purple underlined parts, right? There's a -6 in every term. There are n terms. The -4n comes from the fact that there are n terms and each of them has a -4. So all that's left to do is do this, looks like it's going to be, well, keep it in orange, plus 2 times 1 plus 2 plus blah, 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 plus n, 8 over n. And all of this is being multiplied by 8 over n. Right? And we can make that a little bit nicer by saying, okay, -6n plus -4n is -10n plus, let's make this 1 plus 2 plus blah, blah, blah plus 8 plus n times 16 over n, right? 8 over n times 2. 8 over n. Now at this point, we use our identity, right? We use the identity that I mentioned in class. Right, we get negative 10n plus, and then this is the same thing as n times n plus 1 over 2. Again, well, let's use this guy right here. This is the same as this. That's just an identity. You don't need to memorize that. I will always give that to you. And now you can do some simplification. Right, so we're going to get, I guess at this point I would multiply the 8 over n through. So we're going to get negative 80 plus, okay, 8 times 16. What is that? 140. No, it's 128, I think. Pretty sure it's 128. Yeah, 128 over 2. Actually, we can just do over 2. So I guess it's really 64, right? If we do that, I think that gives us 64. So we're going to get 64n squared plus 64n all over n squared, right? A lot of simplification here, right? Just to be clear, all of this became this, okay? And at this point, I think this is a limit that we can take, just like we did in the last class. In fact, I don't even think we need to write the limit anymore. We just take the limit. Negative 80 plus 64. And just to be clear, the 64 is coming from here. We don't even care about the other 64. I should say 64 comes from here and from there, right? It's a coefficient of 1. All right, and so I guess our answer is negative 16. And remember, that is a fine answer. That is a fine answer because we're talking about the net area under a curve. So this curve seems to dip below the x-axis, at least for part of the time, on negative 3 to 5. And maybe if we go to Desmos and take a look, we can verify that. (2x minus 4) from, what was that, negative 3 to 5. So if we ignore our endpoint approximations, we can see that, yeah, it looks like it should be a negative area, right? We could actually verify this if we wanted, right? Verifying this, it looks like we've got a triangle of base, the right triangle is a base of 3 and a height of 6. So that should be an area of 9. And then this triangle appears to have a base of 5, right? 2 minus negative 3 is 5. Height of 10. So that's negative 25, right? So negative 25 plus 9 gives us negative 16, which was our answer, right? So let's take a snapshot of this. Stick that in our notes. Maybe crop it a little bit. All right, and now we've got a little bit of verification. All right, let's just fill in our areas. Negative 25, 9. A equals negative 25 plus 9, which is negative 16. And that is, in fact, the same thing that we got before. All right, thanks for watching.